All right, here's web development explained in 10 minutes. We'll cover 6 critical areas of web development, which together form a complete web development stack. That means we'll start with user interfaces and the front-end code they're made of. We'll talk about APIs and how data gets transferred over networks. We'll touch on backends, databases, security, the hardware servers run on, and modern cloud computing. But before any of that, let's look at how web development has evolved over the past 20 or so years. We started with Web 1.0, the era of static web pages that essentially just displayed information. We had the .com bubble, Seinfeld, AOL, and a lot of web pages that looked like this. In other words, they were very useful. In the mid to late 2000s, Web 2.0, the era of dynamic web apps, started to emerge. While there's no agreed upon definition, web apps are usually characterized by user-generated content, push notifications, and all the other things that give us anxiety. Now, many believe we're entering a new third era. Customized AI-driven experiences that are different for every user. 2 examples are the YouTube recommendation algorithm, as well as Amazon knowing what we want to buy more than we do. These advances have blurred the lines between web development and the rest of software development. Let's dive into our stack, starting with front end. Notably, this is what the user sees and interacts with directly. It's the portal from our app to the outside world. Most everyone is familiar with the front-end trinity, HTML, CSS, and JavaScript. It all starts in the browser though when you visit a URL. This will kick off a request for index.html from Google servers. An HTML file is only made up of 2 things. We have text and, more importantly, tags. These tags can modify text, add links, break our page into sections, and add classes that we can apply styles to. We also have standalone tags. Essentially, these tell the browser to load additional assets, whether that's an image or additional files. One such file might be a CSS file, which creates an additional request to the Google servers. When we receive it, it'll scan through our loaded HTML and add styling. This is done through selectors and attributes. Selectors find elements and can be broad, searching for all matching a tag, or more narrow with a class or ID. And attributes are the styles we apply. Here's some examples. Something nerve-wracking for all people learning CSS is how to do spacing. You can do 95% of your spacing if you master something called Flexbox. I'll leave a great link in the description to learn this. CSS isn't logical. It's mostly just practicing, memorizing, and applying what you've learned. For this reason, Google's your friend. Back to our HTML file, there's one more important tag we need to talk about. It's the script tag, which allows us to load JavaScript files from our server or elsewhere on the internet. By the way, servers that send these kind of files we're talking about are generally referred to as web servers. So we see a script tag, we request our file, and it gets sent over. Let's look at some of the stuff JavaScript is responsible for with an example. Let's say we have a button that logs us in. What triggers the login is known as a user event or a click on the button. To respond to this event, we need what's known as a listener, some code that waits for the button to be clicked and responds accordingly. When the click happens, JavaScript can update our HTML to show a loader. So JavaScript would update the appearance of our page. We then send this login data to our server to validate it. JS lets us talk to our server without reloading the page. These kind of requests, whether it's to send data or request more data, are known as AJAX, asynchronous JavaScript, and XML requests. In 2020, almost all front-end developers are using frameworks. Here's a few frameworks ranked from easy to hard to learn, and here's them ranked by usage. These frameworks don't do anything JavaScript can't do, but they give us a better developer experience, which when you're making changes or fixing bugs is pretty much everything. That being said, browsers can only run JavaScript, not framework code. So our framework code has to go through a build or bundle step, which converts it to normal JavaScript. The important part is to choose one and stick with it. Although keep in mind that React and Angular have an order of magnitude more jobs than the other 2. Okay, we have our front end, but how does it talk to the back end? That's the purpose of an API. Essentially, our front end and back end may or may not be in different languages. So how do we standardize a way for these 2 to talk? Well, we do that with what's called an API. Most commonly, REST APIs are used, which follow the convention of combining a verb with a location. For example, we might want to get a list of accounts or add a new account. Alternatively, if we pass a parameter, we could get a specific count, modify it, or delete it. REST does give us some nice standards, but there's no guarantees. If anything changes, our front end can get messed up. So there's an alternative called RPC, which sets rules in advance with something called a schema. These make inputs and outputs explicit in advance. Now, how's data transferred? Well, that's done most commonly by sending strings back and forth through a protocol known as HTTP. Ideally, these strings can be read by any programming language. Two common formats are JSON and XML, and we convert data to a JSON string through a process called serialization. So web development backends. Our backend application layer can glue together multiple different components. We can talk to front ends, other servers, and databases. You can write web backends in pretty much any language, but the most popular are Python, JavaScript, PHP, and sure, C# too. Backend frameworks are commonplace too to make your life easier, and here's the most common one for each language I mentioned. If you're wondering when we would talk to other servers, backends are often broken into what's known as services. This is just a pattern to separate logic that can make things easier to scale and to work on. Other than responding to APIs, backends might do various other batch processes, which are often done on a timer. One example of this could be web scraping. To talk to databases, backends often use what's known as an ORM. These just give us more semantic ways to query our database, add to it, and so on. There are entire college courses on databases, but let's talk about them at a high level. There are two main types of multifunctional databases, namely SQL and NoSQL. Each provides different strengths and guarantees. SQL databases are organized in a strict column representation format. That means to write or add to the database, you have to adhere to the set of rules or it won't work. These stricter rules allow you to do more complicated things when you're reading from your database. Alternatively, NoSQL databases don't really have rules. They just have collections, which are groups of objects. So a user object might have name and email, but it's not enforced. These scale much better, but you have to be careful because there are no guarantees about the structure of your data. Again, there are many more database principles that apply, and which you use is totally circumstantial. The three most popular databases are probably MySQL, Postgres, and MongoDB. Finally, you should know that when we're trying to scale up our application, databases are usually the slowest and they're the bottleneck. And resolving these scaling issues also has entire books written about it. Let's touch on web security. Any web app with a login will need to consider authorization and authentication. The login itself provides authentication. Authentication will usually give the user a string-based token that is a random sequence of characters. This is then used on the server side to validate each request. Authorization, on the other hand, defines different user roles. So if I'm an admin, I would be able to do different things than a normal user. We're almost to the end. Let's touch on infrastructure and networking. Data centers are pretty much where all servers and web servers exist, unless you have a dedicated server running at home that's always on. These servers are just computers without monitors that are constantly running. They can be controlled with SSH, a direct way to control the machine from the command line. But most of what they do is automated through scripts. You can group multiple servers into a private network. Each server in a network is called a node. And in private networks, servers can communicate quickly and securely. Servers that talk to the outside world have more to worry about. They're usually set up with a reverse proxy. It's a gateway that exposes specific ports to the outside world. A port just being a machine-specific address a process is running on. So you might want to expose a REST API's port, but not a database port. Nowadays, most of this hardware management is handled by companies like AWS and DigitalOcean who run their own data centers and rent out space on demand. This is where the term cloud computing comes in. You can rent a fraction of a single server for an hourly or monthly cost. Cloud providers like AWS will usually offer a lot of additional free services to keep you on their platform. Cloud computing has expanded beyond just having servers as a service though. You could run individual functions for a very low cost on demand too. So if I wanted to send an email every time something happened in my front end, I could put that in a cloud function. Moving on, if everything after the front end section was not getting you that excited in this video, then you can actually now use an entire backend as a service. That means everything from database to API configuration to security is handled by the service. This means you can get apps up and running in a matter of hours, and it's really easy. One example is Firebase. It's a service I love and use all the time. Anyway, guys, that was web development in 10 minutes. Please like the video so more people can see it, and subscribe if you want more web and software development content.